Look at power transmission. There are two reasons why we want to use alternating current in our homes. The first one, I've just shown some calculations here, which I'm not going to go through now. I just want to get to the reasons. The one reason is that with alternating current, there's less of a voltage or a power lost in transmission. Because remember, from the power plant, you have to take it sometimes 200 kilometers, sometimes further to get to your home. During that process of getting that electrical energy, that electricity to your home that you've generated, there is a huge loss in power, okay, compared to when I'm using alternating current. So the first reason would be reducing the current ensures less voltage lost in transmission. So with alternating current, I can reduce my current and I will have less power loss over large distances. All right, the second one would be, it's easy to step up or step down your potential difference and your associated current through alternating current. So that's stepping up or stepping down. You can see at the power plant, we've got 250,000 volt potential difference. And I can easily step it down to the 240 volt that I want in my home. Where with direct current, I can't step it up or step it down. So that is the reason why we also want alternating current in our homes. And that is the two reasons. Less power loss with alternating current over large distances. And secondly, it's easy to step up or step down the potential difference. All right, so that is what I've just shown there. Okay, now let us go to examples of questions or calculations with alternating current. Okay, this is a question from an old exam paper. So we know that this is on the standard that you can expect in the exam. Let us read together through this question. Right, it says, AC and DC generators. So for me, this word is very important. Generator. So immediately I'm thinking of the energy conversion, what kind of the rules I can use, what is the principle on which it is working, all of that information. Then I'm looking at a diagram. It says AC and DC generators differ in their construction. That's true. And the type of current they deliver. The simplified sketch below represents a DC generator. So here they've shown me a DC generator. So this one will deliver direct current. All right? And I can see why. Because the DC generator is linked to split rings. Alternating current generator, I would have seen slip rings there. Okay? So that is quite nice. I see my magnetic field, my magnets is there, so I will have a magnetic field that is in that direction. Which rule will I use? I will use my right hand dynamo rule if I want to know direction of turn or direction of induced current, depending on what is asked. The reason I haven't even looked at the question yet, but you can see I'm already looking at lots of possibilities, and I want you guys to start to be able to do that. The moment when you get a diagram, let it be a simple direct current diagram with cells and resistors, or let it be electrodynamics where you get a generator or an electrical engine, a machine. Immediately think of what is possibilities here. What rules can I use? What principles? And all those things that goes with that. Okay? Yeah, so let us now look at the question. Which component enables the generator to produce direct current? All right, of all the components here, there is only one that in the case of a generator where I am turning it, okay, there is only one component which will determine that DC is produced, and that is the slip rings, or the split rings in this case. So that answer will be Q Q. All right. And if you were asked to put it in words, you would have said split ring commutator. So there's your answer. But in this case, they said P or Q. So you could have just said Q. All right. What structural change must be made to this generator to change it to an alternating current generator? Right, I have to replace Q with slip rings. So Q, instead of the split ring, I would have used slip rings. Replace split ring with, and that was Q, with slip rings. Okay, now briefly explain why Eskom prefers using alternating current instead of direct current for the long distance transmission of electricity. We've just gone through it. Now when you see 2 marks, guys, that 2 marks, it's always important to look at mark allocation. Then you can know, listen, but I should maybe come up with 2 reasons. All right, and we've just dealt with that. The first one would be, it can easily be stepped down or up. Okay, stepped up or down at the power stations. Why? To reduce power loss. Okay, so those are my 2 things that I want to see there. The potential difference and the current can easily be stepped up or down, and I have a reduction in power loss. Okay.